presentation, which is called Sedimentary Geochemical Signatures of Recent Sea Level Change in the Cerro Coastal Lagoon, Northwest Mexico. And that is part also of the same project that is evaluating sea level rise from coastal sediments. Well, I want to start with this slide, which focus or gives an example of what is sea level rise. Sea level rise is one of the most important effects of climate change due to global warming. Now, nowadays, warming of the climate system is unequivocal, and so it is sea level rise. And the reason why sea level rise is given such importance lies in the following reasons. First of all, the mean rate at which sea level has risen during the last century is larger than the mean rate of the last 2 millennia. And it is about 1.7 millimeters per year. And in addition, the rate in between 1990 and 2010, it is about 3.2 millimeters per year, which is about the double of the rate of the last century. Besides this, the new projections of the IPCC for sea level rise indicate that it can be a sea level rise between 53 centimeters and 1 meter for the year 2100. Now, all these facts and projections increase the concerns about impacts on the coastal zone and over the vulnerable population, which is, who are these people whose way of life is constantly threatened by ocean inundation. Now, in this respect, tidal marshes and tidal marsh sediments are a good alternative to understand and study recent sea level changes in these areas. Tidal marshes are ecosystems that grow along the upper intertidal zone. This is over or above the mean spring tide level. And when tidal marshes and mangroves coexist, which happens in Mexico, tidal marshes are usually found at higher elevations where they are inundated with less frequency. Now, there is another characteristic about tidal salt marshes, and it's that they are very sensitive to changes in the height of mean sea level. Now, this is a characteristic that we like a lot because based on this assumption, we work with the hypothesis that in order to preserve themselves, tidal marshes must have an accretion rate which is in equilibrium with sea level rise. Now, marshes, as well as other coastal ecosystems, respond to the influence of the ocean and of the continent. And all these changes are recorded on the sediments, but how can we interpret this data and translate it into a sea level rise scenario? Well, there are a group of elements that play the role of indicators and can help us to understand what is going on over these areas. For example, there are this group of elements, sodium, chlorine, and bromine, which are going to tell us about the influence of the ocean over the sediments. And on the other hand, this group of elements, aluminum, titanium, potassium, and iron, are going to tell us about the continental influence over the sediments. So we dig into the variations of these elements over 3 different marsh areas of the Cerro Coastal Lagoon. As Dr. Carolina explained before, the Cerro is located in southeast part of the Gulf of California. This is Northwest Mexico, just below Mazatlan City. So we took 3 sediment cores manually over 3 different marsh areas. And then, before the laboratory analysis were done, we subsectioned each sediment core into 1 centimeter sections. And then the samples were lyophilized and ground to powder. we made an analysis of a grain size analysis, and it was performed using a Malvern grain size analyzer. And the elemental composition was made with the spectroscopus X-ray fluorescence spectrometer. So once the laboratory analysis were done, we performed a factor analysis. And basically, we included as variables those elements that could be useful as indicators. And also the grain size and organic matter, because we know that clay materials can absorb some elements, and also the organic matter can complex some of those elements and concentrate them on the sediments. So we use them all as variables in this factor analysis, and what we observed is that they were two main factors that together explain 63% of the total variability of the data. And one of the factors, the main factor, which we denominated provenance, explained 48% of the variability. Now, this factor grouped on with negative loadings those elements that can explain the marine influence over the sediments, which were sodium, chlorine, and bromine, and with positive loadings, those elements that are talking about the continental influence or terrigenous input to the sediments. So the sample projections of the core EU1 showed a more terrigenous influence or terrigenous material in the bottom of the core, and from the sections 47 to the sections 21, 22, and then this influence diminished up to the surface. In contrast, the projection of the samples of the sediment core EU3 had a more marine characteristic, and this marine influence reached its maximum point at the sections 22 and 21, and then it diminished up to the surface. Now, all these results were consistent with the geochemical profiles, depth profiles of our geochemical indicators, which were in blue, those that are telling us about the marine influence of the influence of the ocean over the sediments, and then the terrigenous input that is in orange. So what we observed is that there was a significant change on the concentrations of bromine, chlorine, and sodium that are suggesting a sea level rise scenario. Also, the concentration of the terrigenous indicators indicated the opposite trend. Now, as conclusions, we had that changes in sodium, chlorine, and bromine concentrations of sediment cores can be used as indicators of sea level rise in tidal marsh sediments. Traditionally, sodium and chlorine concentrations have been used as paleosalinity and marine indicators in sediment cores. However, based on the factor analysis that we performed and in this study, bromine concentrations can be used as well as indicators that evince a marine input to marsh sediments. Titanium, potassium, rubidium, and zirconium concentrations also can be used as supportive evidence of sea level rise in salt marsh sediments when these concentrations show a dilution trend from the bottom of the core to the surface of the core. Well, finally, I want to acknowledge to all the institutions that made possible this study, as well as all the crew of the lab that are working together in this project. Thank you very much.
Question.
Yep.
How do you account for bioturbation? There must be crabs and worms kind of churning that top soil.
Yeah, there usually are organisms and, also mangrove areas, but we we prefer. That's why we're looking for these tidal marshes that are behind mangroves to try to not to found bioturbation of at least of plants. The crab, the bioturbation that can be found by crabs, it can be evaluated with the lead 2010 profiles that show exponential decay. That will indicate us that the sediment core is not mixed up, and that will give us an idea of the level of bioturbation. Yeah.
Have you considered other reasons why you might see that change? For example, changes in the sediment flux from the catchment, or as the elevation of the tidal marsh increases, that there's less terrigenous sediments making it into the marsh. I mean, have you considered other variables, environmental variables?
Yes. Besides the influence of the ocean, of the input of those from the ocean, we also are in the group of in this multidisciplinary group. They are also evaluating the tectonics of the site to see if the land is moving up or down. And what they told us is that this was about 0.1 millimeters in the last century. So.
What about the sediment flux from the catchment?
The sediment flux
from the catchment.
From the continent, is it? Or
the watershed.
The watershed.
Watershed. Okay. I think those sediments are explained with the terrigenous indicators. If they come up of the continent.